Hello everyone! In the previous video, we connected the main components of our chilled water system, chillers, pumps, and buffer tank. Now let's move one step further and start thinking like real engineers. So, we decided to use DN200 pipe manifolds. Now let's take a look at typical flow velocities in water systems. Here you can see recommended velocity ranges depending on application. For example, cooling water systems usually operate around 1.5 to 2.5 meters per second. This is exactly the range we're targeting for our chilled water system. We detail the chiller connecting pipelines using this table as a reference. We can check whether our piping design makes sense. If velocity is too low, the system becomes inefficient. If it's too high, we get noise, higher pressure losses, and potential pipe wear. So, our goal is to stay within this recommended range while balancing efficiency and system stability. Then quickly look at how I imagine our chiller. This is a large industrial unit, not a small toy. We're talking about a box roughly 2 by 2 by 5 meters in size. Now let's add some components to the inlet and outlet lines of the chiller. The idea is simple. We need to protect the equipment and make the system easy to maintain. On the inlet line, the first component is a strainer. It protects the internal components of the chiller from dirt and particles. Next, we add isolating valves. This allows us to shut off the flow and service the strainer when needed. Butterfly valves are very commonly used as isolating valves in water systems. In our case, I place the butterfly valves directly at the ends of a strainer. This creates a kind of sandwich arrangement. By using wafer-type butterfly valves, we can install them between flanges and reduce the number of separate connections. This helps save space and simplifies the installation. On the outlet line, we install an isolating valve and a balancing valve to control the flow. We also add a thermometer for quick monitoring of system performance. Water always takes the easiest path, so the closest pipe gets the most flow. Balancing valves help us correct that, so every part of the system works properly. Let's also talk about the thermometer on the outlet line. Its purpose is simple: to quickly check the temperature of the water leaving the chiller. This helps us verify that the chiller is operating correctly. In addition, I install a thermometer on the inlet manifold to the chillers and on all outlet lines. This allows us to monitor both supply and return temperatures across the system. Here, I can either use a simple thermometer from the program library or insert a detailed 3D model. If you want your isometrics to look correct, you need to convert these 3D models into plant 3D components, not just solids. For now, I'll leave it as a dummy unit. As mentioned before, we place one thermometer on the inlet manifold. While editing this video, I noticed one major mistake in the chiller manifold. If you spot it, write it in the comments. It will be interesting to see who finds the correct answer. This highlights an important point. When modeling systems, you have to double-check that everything is properly connected. Now, let's slightly reposition the components to make it easier to place pipe supports. I like when supports and other components are aligned and follow a clear order. To save time, let's copy the setup to the other chillers and move on. I'm also considering adding isolating valves directly on the manifold. It's not strictly necessary, but it can be very useful. With these valves, we can isolate a single chiller without shutting down the entire system. However, DN200 is already a large pipe size, so these valves are not cheap. That's why we always need to evaluate the cost versus the actual benefit. I also add isolating valves directly on the buffer tank nozzles. For example, if the buffer tank needs inspection, cleaning, or repair, we can isolate it without shutting down the entire system. Right now, our custom-made valves look a bit silly because the proportions are off. Let's fix that and make them look more realistic. The maintenance worker would not be very happy with such a small service area. So let's move the buffer tank a bit further away from the wall. And after that, let's quickly take a look at how a strainer looks in real life. We're looking for a flanged version, not a basket type, and much smaller. The first example fits best. Now, let's take a look at how a butterfly valve looks. In this case, I'm thinking about a wafer type valve with lugs. This type of valve is installed between two flanges. And finally, let's take a look at how a balancing valve looks. So, this is how our chilled water system looks at this stage. In the next part, we'll move into calculations and start selecting real equipment. Thanks for watching, and don't forget to subscribe for more.